Hi, it's Terry Dennery of the MathWorks. So, anyways, this video is going to essentially be a redo of kind of the first video we did, which kind of introduced this series. But we're going to be a little bit more attentive to that kind of exemplary task that we did in that one, which was motor selection, and be very kind of specific on this. And as well, I think having produced as well as possibly viewed the previous videos, I think we have the context to kind of understand where all this is coming and why it's such a credible way of doing things. So um, anyways, let's proceed with this. And and so you may recall, all right, that we had a very, very good agreement between what we're asking it to do and what we got. What we did on that one, though, was we commanded motion. We showed motion as far as position versus time as opposed to velocity. And so I want to kind of replicate that. Again, our real primary objective here is to rotate the shaft 1 revolution or 2 pi radians, right? And so with that selector now selecting on the first component, that will be position. We'll kind of line that up like that. And since what we're getting out of our plant model, the mechanical shaft, is velocity, we do need to introduce an integrator. And so just type in INT for integrator. We'll put that in right there. Okay, and let's check it out. All right, it looks really great. Okay, and so now let's do the thing we did in the previous video. Let's do the harder thing. And so instead of a transition from 0 to 2 pi taking 3 seconds, let's make it way faster. We'll do it in half a second. So 6 times faster. All right. And this time we're going to see something different than what we saw in the initial video, which is that we do really well. All right. And so let me get into kind of the explanation of the model now. All right. And so what I want to do is I want to scope the voltage. All right. And we'll hit run. And we'll see that, in this example, there are no constraints at all on the voltage that we are going to deliver, right? And all I can say is if this is a 30-volt motor and we, try to apply 200 volts, I don't think that that's good for the motor. And there's a good chance you'll burn the motor out, all right? And so, there's lots of ways you might protect your motor, but quite often it's done through the controller. And so, the controller is choosing the voltage. Well, let's go ahead and output what it's going to deliver. Right? And so I'll put in 30 volts and minus 30. So can't go above 30, can't go below minus 30. All right. Okay, and now I think we'll see something very similar to what we saw in the first video, which we do. Okay, and it really just can't cut it. I am going to do something just so that we can kind of analyze a little bit better. And let's just run this for, was it half? Okay, I think 2 seconds will be enough. And I like how that just kind of distributes kind of the measurement so I can see it a little bit more clearly. But clearly the commanded voltage in or commanded motion in yellow is not what we're seeing from this system, right? And so now I think it begins to make sense. Well, why we choose these things? At least I think having produced the last couple of videos, I think what I want to say, we have a bit of the context and the credibility in the approach because we understand where it's coming from. So anyways, let's go ahead and this time, let's scope the torque and let's scope the velocity. All right. And we'll see that oops, got to use another selector block. That is what's delivered, which falls short. So let's get another selector block. This one will go on the second signal, which I know to be velocity. clear a little real estate. And let's send that in. Okay, and now let's hit run. Okay, and it comes in just short of 20 radians per second, but we'll see that the torque requirement is much higher than that. Whatever that is, maybe 130, 140 Newton meters. That's torque, right? Yeah. Okay. All right. And so again, these are not perfect parameters. It's a combination of torque and speed that really needs to be satisfied. And I will kind of make the case that these do map out an envelope of operation, and that maybe you can work effectively by putting in, let's say, a margin of safety. And so if it's asking for like 130 Newton meters, let's try 200 as the stall torque. Again, it will not be able to deliver anywhere close to that once it starts moving, but maybe if I set that at 200, it will work out nicely for us. And the speed, I'll put that at 40. All right, and let's hit run. And so again, you can see we're doing a beautiful job. And now, the voltage isn't going up to 200. It's actually hitting our 30-volt requirement quite nicely. So anyways, maybe my main point here is, the Simulink and this approach supported by it, it's a great way to choose your motors. And it's that case, very much in part because it's one environment for the mechanics, the electrical actuation, and the controls. All right. So thank you.